Hello viewers, we want to continue with our combination, and today we want to consider the properties of combinatorial coefficients. Combinatorial coefficients. For today I'm going to list like 3 of them. Now the first one says that n Cn is equal to NCO, and it's 1 actually. That's NCO, and that is actually 1. So now by that, what do we mean? It can be proven. So if we have, okay, say this one now, NCN is like saying n factorial, n minus, of course, n factorial, n factorial. So this is equal to n factorial, 0 factorial, n factorial. This cancels out this 1, 1. Of course, 0 factorial is also 1. I hope you know which is answer 1. Is that correct? Then also NCO, n combination O, or 0, is of course n factorial, n minus O factorial. Remember our formula. Then n factorial. Check my previous video for the formula for combination. That's why you understand what we're doing. Then it's equal to, if you subtract this, you're going to have, O factorial, I mean to say, O factorial. Then if you do this, that's n factorial over n factorial O factorial. Then this is 1, 1. Of course, 0 factorial is 1, so 1. So this and this are equal. So that's this equal to this equal to 1. Okay, the next one we want to also look at is the fact that n combination R is equal to n combination n minus R. That's what I want to consider. That's what I want to look at. This can give you this. So if you employ the formula, I hope you note. If you know the combination formula, note that n combination R usually, of course you know it, n minus 1, n factorial all over n minus R factorial R factorial. I hope you know. So going by this now, we have n, of course this, we've always stated this. So let's try this and see whether it will give us the same. So if you have n minus R, it's going to be n factorial, then n minus this one now, of course you know, minus, let me say brackets, n minus R factorial, then n minus R factorial. That would be n factorial, then n minus n plus R factorial, you understand? Then n minus R factorial. Then this will cancel out. It becomes n factorial O So this one will cancel out. So it becomes this minus this is nothing. So then we straight away write, bring down r factorial, then n minus r factorial. I hope you know this covering this covering all this. So that's what we have. I hope you get it. So this, now if you check closely, this, even though it is switched, it's same thing as this. So this has been proven. Therefore, we can say since this is same as this, then you have that n equal to n c n minus r. Sorry, minus r. So this is it. Okay, so let's treat some examples. If we were to treat some examples, they might say examples without evaluation. Oh, there's the third one I'm supposed to have stated. Okay, let me just state it. Let me state it before I continue. Let me state it. The third one is that NCR plus NCR plus 1 is equal to N plus 1 C combination R plus 1. So that's the third one. Now this one is more involved. I'm going to prove it separately so that I don't lengthen the video. Okay, let me continue with my example. Let me continue with it. Okay. Now you might have, they say without evaluation, of course this is an example. Without evaluation, explain that 25 combination 10 is same as 25 combination 15. Simple. You can just state the one of the properties. Which of them will have this one, NCN, NCO is that one. We also have this one. I'll have this one also, this and this. I think it is this and this. So you can say just because okay, let me put it this way. 25 combination 10 is equal to 25 combination 15 because NCR is equal to NCN minus R. That's all. The B part, you might see something like without evaluation, explain n combination 3 plus 5 combination 4 is equal to 6 combination 4. Simply, you can say this is because of this fact. What fact now? This very fact here. So we can write that n C r plus n combination r plus 1 is equal to n plus 1 combination r plus 1. I think that's it. Okay, let's use some other examples. Other examples. You might see something like, you say, how many different arrangements are there of 9 cakes on a table having 15 chambers. So what do we do? Solution. So this is a combination problem. Solution is simply saying 15 chambers, you're combining 9 things. So that will be 15 factorial all over 15, going by the formula for combination. 9 factorial, that would be 15 factorial, 6 factorial, 9 factorial. With your calculator, you are going to get 5005 as the answer. This is the A part. Sometimes the B part, or number 2, you might say 50. About 50 combination 50. Remember, it's equivalent to saying n combination n, which is equal to r. Of course, if you want to solve it, so let's say n combination l, which is equal to 1. But if you want to solve it, that's 50 factorial, 50 minus 50 factorial, 50 factorial. That will give you 50 factorial, 50 factorial. This cancels out with that, 1, 1. 0 factorial is always 1, so our answer is 1. So thank you. See you in the other video. Thank you so much. Have a great day.